Hello and welcome everyone. And so far now we have discussed a lot on waterproofing and dam proofing. So let us discuss some more methods of dam proofing, especially on different elements of the structure. And then what are the precautions that have to be kept in mind while doing dam proofing? So dampness is because of presence of hygroscopic or gravitational moisture on the walls or the members. So this hygroscopic salt which is present in the bricks has a deep affinity towards the water, and the gravitational moisture is due to the rainwater trickling on the walls. So due to dampness the strength reduces drastically, and also it leads to unhygienic condition. So the damp prevention is therefore one of the most important factors for building design. So there are different causes of dampness, and there can be a series. There are only few which have been listed here, like moisture rising up the walls from the ground, subsoil due to capillary action of porous concrete, or the rainwater which is traveling from wall tops. So that's why we do coping on the parapet wall or the compound walls, or it may be the rainwater which is beating against the external walls of our house, or there can be poor drainage at the building site, or it can be possible that there are various defects in the construction. So the effect of dampness is so many, starting from the breeding of mosquitoes, and moisture also cause unsightly patches, development of molds in the corners, green and white molds, and it also causes softening of plaster, and there are efflorescence development on the plasters, and it also causes disintegration of stones, bricks, mortar, and the spalling that we have explained because of rusting and corrosion of the steel reinforcement bars, and it also corrode the metal fittings in the doors, windows which we have used significantly. That's why we see in the bathroom the doors and windows are severely affected if there is damping, or it can be that the floor coverings are damaged. So there are different precautions that should be taken to prevent the dampness in building before applying the various techniques and methods that we will be going to discuss. So let us understand precautions first of all, and only on that basis we can apply the different techniques or the methods of damp proofing on different structural element. All right. So the first precaution that we can take is that site should be located on a high ground and well drained soil to safeguard against foundation dampness, and it should be ensured that the water level is at least 3 meters below the surface of ground or lowest point even in the wet season. So for better drainage the ground surface surrounding the building should also slope away. So basically our structure should be at height and there should be proper drainage and water table should be below. All the exposed walls should be of sufficient thickness to safeguard against rain penetration. If walls of bricks, they should be at least 30 centimeter thickness, and bricks of superior quality, well burnt bricks which are free from defects such as cracks, flaws, lump of limestones should be used, and they should not absorb water more than 1 by 8th of their own weight when soaked in water for 24 hours. So this is one of the tests on bricks that we do in the labs. And then of course we have to use very good quality cement mortars to produce a definite pattern and perfect bond. There are different bond in mortar, English bond, Flemish bond, in building units throughout the construction work. This is very essential to prevent the formation cavities and occurrences of differential settlements. Next precaution is that the cornices should be provided. See, all these elements are very, very important. Like window sills is very important for the protection of window. Coping of plinth should be sloped on top and throated on the undesirable to throw the rainwater away from the walls. So we have discussed beading that we do and the coping we do on the parapet walls. All the exposed surfaces should be covered well with waterproofing cement plaster. And the hollow walls are more reliable than solid walls in preventing dampness, and hollow walls are also known as cavity walls. So we prefer cavity wall construction wherever possible. Now what is cavity wall? Cavity wall, we can use AAC block. Okay, now AAC block, you will see there are cavity inside the block itself, or in cavity wall we make two walls with a cavity left between these two walls. Okay, so these all types of wall you must have read in building construction also. So let us discuss some methods of damp proofing, and the first one is the use of damp proofing courses, DPC or membranes. So these are the layers or membranes of water repellent material such as bituminous felts, mastic asphalt, plastic sheets, cement concrete, mortar, metal sheets. So this is DPC, and this we have discussed in detail that it is provided to prevent the water rising from subsoil and getting into the different parts of the building. So the best location chosen for DPC without basement lies at the plinth level. Okay, and in case of a structure without plinth should be laid at least 15 centimeter above the ground, and these DPC may be provided horizontally or vertically on the even on the vertical floors or the walls. Okay, now this is the diagram, and here this is the ground level, and we have provided DPC damp proof course, and it is provided slightly above the ground level. Okay, and above DPC you see here is the ground level. Okay, and if you see above this ground level, now this is my level of DPC. Okay, and my floor finish is here, and this is the lime or cement concrete, and this is normal filling being done by the soil under floor, and here is my level of floor beginning. Okay, so all these levels should be clear. Floor should be above DPC and DPC should be above ground. All right. So this we have discussed in detail also, and in this 3D diagram also you can see the same thing. If this is my normal ground level, okay, so this is my external brickwork, and DPC is provided on the plinth. Okay, and above this my timber floor. Now in this case timber floor, wooden floor is used, so this is my floor level. All right, so this is about the DPC, and mastic asphalt is also provided. So the asphalt and bitumen are mostly used as waterproof compounds. So there is another method, and in this method we do the surface treatment. Okay, so sometimes we write waterproofing or damp proofing, don't get confused. Damp proofing and waterproofing both are done combiningly. All right, see if the water table is really very high, and in that cases water can seep directly into the structure, and if water is not there but there may be the chances of dampness coming into the structure, so for that also damp proofing has to be done. So both has to be done together, and both are almost having similar types of treatments. So here the surface treatment consists in filling of the pores of the material exposed to moisture. Now this we have discussed in negative side of waterproofing, where we provide a thin film of water repellent material over the surface, and these surface treatments can be either external or internal, means positive or negative. Painting, distampering are given to the exposed surfaces and also to the internal surfaces, and here We use mostly lime cement plaster of mix, and this is the ratio of 1 cement, 1 lime and 6 sand water per person. And a thin film of waterproofing material generally employed as waterproofing agent, and different chemicals are also added in the mix. Next type of damp proofing treatment is the integral damp proofing treatment, and it consists adding certain compounds to the concrete or mortar in itself during the process of mixing, which when used in construction act as barrier to the moisture penetration under different principles. Now there are few compounds which are very important, and you can remember they are like chalk, talc and fuller's earth have mechanical action principle, and they fill the pores present in the concrete or mortar and make them really impervious, denser and waterproof. So that's why it is called integral damp proofing. Means in the cement, mortar or the concrete itself you have added few compounds integrally for damp proofing. So there are a few more compounds, and they work on chemical action principles, and they react chemically and fill in the pores to act as water resistant. Okay, so these are the compounds like soaps, petroleum oils, fatty acid compounds such as stearates of calcium, sodium, ammonium, sulfates, etc. Now the cavity wall which I was talking is also a method of damp proofing, and a cavity wall consists of two parallel walls, leaves, skins, whatever you say, of masonry walls. Means the normal brick, there are two cavity wall parallel, and they are separated by a continuous air space or cavity between these two parallel walls. Okay, and they consist of three parts. One is the out wall, which we call leaf also, and it is generally 10 centimeter thick, and then there is cavity. After the outermost wall there is cavity or the air space of almost half 5 centimeter thick, and then there is inner wall or leaf, it is again minimum 10 centimeter thick. So these two leaves forming a cavity in between may be of equal thickness or may not be, and provision of continuous cavity in the wall efficiently prevents the transmission of dampness from outer to inner wall. Now what will happen, that under different humid condition the water or the moisture will try to come from the outer wall to the inner wall, but there is cavity, so maybe the outer wall may be affected, but the inner wall is separated from the outer wall by the cavity. So our inner wall or the inside environment of the home will remain really sanitable. Okay, and cavity type construction is most desirable under climatic condition of India, like hot, dry and hot, humid, as it offers many advantages such as better living and comfort conditions, economic constructions and preservation of buildings against dampness. So as there is no contact between outer and inner walls of a cavity wall except at wall ties, so both these inner and outer walls are connected at wall ties. Okay, so at wall ties there is no cavity, which are of impervious material, so possibility of moisture penetration is reduced to a minimum. And it has been verified a cavity wall of 10 centimeter thick internal and external walls with 5 centimeter cavity in between is better or more reliable than solid wall of 20 centimeter thickness with respect to damp prevention. You see the difference? Now the cavity wall offers good insulation also against the sound. So this is my additional benefit of cavity wall. If you want a room or a theater or an auditorium which should be soundproof, means no external sound or noise should disturb the interior environment, so cavity wall is very important. Now it also reduces the nuisance of efflorescence, and it offers other advantages like economy and better comfort. So this is the 3D diagram of a cavity wall, and this is my interior leaf and this is my exterior leaf, and between these two leaf there is the cavity being left, and this cavity is left empty, and we can plaster the walls from external sides. Okay, so this is how cavity wall looks like. Then the next method of damp proofing is soft concrete, and this is called gunting, and it consists in forming an impervious layer of rich cement mortar for waterproofing over the exposed concrete surface for resisting water pressure. So here gunite is a mixture of cement and sand, and it is the usual proportion being 1:3 or 1:4, and a machine known as cement gun having a nozzle for spraying the mixture and a drum of compressed air for forcing the mixture under desired pressure. And this is how gunting is being done, by forcing the gunite on the walls. Next method is the pressure grouts, and in grouting we do the cementation by providing cement slurry under high velocity. So here cementation is the process of forcing the cement grout. Cement grout is the mix of cement, sand and water under pressure into cracks, voids, features present in a structure component or ground, all the components of a structure in general and foundation specifically, which are liable to moisture penetration, and they are consolidated and so made water resistant by this process. The grout pumping machine, this is called, and the slurry is being passed through under pressure, and this is the existing footing level of the building, and here this is the hole which is being grouted here. So different material which is used for damp proofing is, as we have discussed, in DPC we use hot bitumen, and it is really flexible material which can be applied with a minimum thickness of 3 mm. Okay, and it is placed on the bedding of concrete. It is always done in the hot condition. And the next type of material is the mastic asphalt, and it is semi-rigid material which is quite durable and completely impervious, and it is obtained by heating asphalt with sand and mineral fillers. So it is also led very carefully by experienced persons. Next type of material is bituminous felt, and this is also a flexible material which is available in sheets or rolls of different thickness, and it is generally laid on leveled flat layer of cement mortar, and we have to provide overlapping hairs at different angles, junctions and crossings, and it is also applied when it is in hot condition. Now next type of material is the metal sheets, and different metals like lead, copper, aluminium can be used as damp proof coursing. And these sheets are quite flexible, and thickness should be such that its weight is not less than 20 kg per meter square. So they are similar to the bituminous felts. So these metal sheets has relatively high durability, resistance to dampness and sliding, etc. So the next type of material is the combination of sheets and bituminous felts. So we provide the lead foil sandwiched between the asphaltic or bituminous felts. It can be effectively used as DPC, and it is a combination of two materials here, and that's why it is known as lead core. So there are different materials and we can do several permutations and combinations. Now is the DPC treatment in buildings. See, in buildings there are different elements like foundation, and then there is walls or there is floors. So all these things have to be treated to prevent dampness. So let us discuss the treatment to foundations against gravitational water which is going through the drains. So foundation may receive water percolating from adjacent ground. Maybe in the adjacent there is some neighbor who has the drain and it is above my foundation. So the water may percolate from his drain to my foundation, and the moisture may rise in the wall of my building. So in that case, the moisture can be checked by providing one extra drain which is called air drain parallel to the external wall. Now this air drain is really amazing. The width of air drain may be about 20 to 30 centimeter, and the outer wall of the drain is kept above the ground to check the entry of surface water, and a RCC roof slab is also provided over the air drain. Okay, and openings with gratings are provided at regular interval for passage of air. So this you can see what we do in case of foundational damp proofing. We provide a air drain just beside our wall, and this is my air drain. Here we do not pass any kind of water. This is only for the passage of air which is left empty here. Okay, so this is a kind of cavity being created here so that the water may not percolate from this adjacent building to my main structural element. Okay, so this air drain will prevent this entry of water here only. Okay, and we cover this air drain by a small slab integrated in the wall itself like this, and we of course we do openings at regular intervals with gratings provided. So this is done in case of foundation treatment in damp proofing. Now how do we treat the basements for preventing the dampness? So it can be done either by provision of foundation drains or DPC, or by provision of RCC raft and wall slab, or by the provision of asphalt tanking. Okay, so these are different treatments to basements. And if we talk the provision of foundation drain and DPC, actually it is done when basement rests on soil which are not properly drained and great hydrostatic pressure is exerted, and the floor as well as wall receive water continuously. So in such a case, it becomes necessary to make a trench all round up to foundation level and fill it with gravel, coke and other pervious materials. And now open jointed drains may be provided to collect the underground water, or drainage pipe embedded in gravel bed may also be provided before foundation concrete. So if you see on the basement, we have provided one special drainage system here, and this is draining the moisture which is coming on the wall. This is my DPC treatment being done on the wall. It is done horizontally like this, and DPC is also done vertically on the wall, and this DPC layer is continued on the entire foundational concrete, and over this we can do our flooring. Now here we have provided a drain pipe. Okay, and this drain pipe is receiving the water from these pervious material. These pervious materials are like gravels, coke, etc., and they receive, this is sand and below this is gravel, and they easily transfer all the water to this drain pipe, and this drain pipe finally drain the water outside. So in this way we protect the foundation concrete and the basement. Similarly, we also provide one extra gravel bed below foundation concrete also, and there we also use drain pipe. Now the next method is the provision of RCC floor and wall slab. So where underground water pressure is severe, now if the underground water pressure really increases to a high level, so in that case the drainage system may not solve the problem effectively. Okay, now the water is applying so much hydrostatic pressure that drainage is not sufficient. So in that case, even constant pumping out water may be costly. You can't do constant pumping of water outside. So in such case, we have to make the floor slabs as well as walls in such a way that they are made completely rigid RCC structure. Even the walls I am talking, or even the floors, entire floor and the wall has to be made a rigid RCC structure, no bricks being used anywhere. And along with this, the horizontal and vertical DPC treatment is also provided, and at least 3 layers of bituminous felt are used as DPC. Half brick thick wall protective is provided at outer face of RCC wall slab also. So here you see the DPC treatment for basement in damp soil where it is huge pressure, and you can see that entire wall, this is the wall and this is the floor, it's all RCC. Okay, RCC floor slab and RCC wall, you see both are RCC, reinforced cement concrete. Okay, and with this we also provide half of the brick size protective wall outside of this foundation, and below that we also do DPC of 3 bituminous layer. Okay, so this is how we do in case of RCC floor slab. And the next type of damp proofing treatment on basement is asphalt tanking. Here subsoil water table is not very high, and in this case we provide horizontal DPC in form of asphalt layer of 30 mm thick in 3 coats over the entire area of basement floor, and extending it in the form of 20 mm thick vertical DPC on the external face of basement walls. And again here 1.5 brick thick outer wall is constructed, and vertical DPC 15 cm from ground is also done. Okay, and this is the cross sectional diagram of asphalt tanking. Beside the main wall, okay, this is my main wall, we have provided a continuous groove for tucking, and this groove is in connection with half of the size of brick protective wall. Okay, and above the foundation concrete we have provided 3 coats of DPC, and then the flooring is done. Okay, so now we come to the damp proofing treatment to the floors. So for locations where ground moisture is not present, subsoil is rammed well, and a coarse sand is spread over the entire area under flooring. Okay, this is normally being done. Or alternatively, stone soling may first be provided, and then we apply a thick layer of lean cement concrete over it, and over this base flooring may be laid. In a damp soil where there is huge hydrostatic pressure and water table is near ground level, it is essential to provide DPC membrane over entire area of the floor. And a layer of flat bricks is laid on a cushion of fine sand over DPC to protect it from damage during the construction of floor slab, just like in brick cover waterproofing we have learned. And this is how DPC for floor is also done. So this was my wall, okay, but this is my floor. Now in normal cases we may ram the soil sufficiently, and above that we provide a layer of sand, and then we can go for flooring. Or if not that, then we have to do stone soling, and above that we can go for flooring. But in damp soil where water table is really near the ground level, we have to do DPC over the entire floor area, and above that DPC layer, which is applied over the lean cement concrete, we also provide the layer of flat bricks course, and above bricks we provide floor concrete over which we can do the flooring. So this is how DPC is being done for flooring. Okay, all right, so this was all about different methods of damp proofing treatment, and specifically on different elements of the structure how we do damp proofing. It is basically done on the foundation and the basement and the walls and the floor, which is specifically in contact with the ground floor, because it is the ground which is the cause of dampness in most of the cases. And as far as waterproofing is concerned, we have learned all the techniques so far now in good detail. So I hope you must have understood by now that how we do damp proofing and waterproofing on different structural element in a normal construction of a house, which is of utmost importance, because if not now, then of course later on the person who is living under the house or anyone who is going to come will really appreciate by seeing the living condition inside the house if we have properly taken care of these small factors which is caused by the dampness or the water intrusions. So we will be discussing on the new topic, that is the termite proofing, from the next videos. So till that, stay tuned and stay safe. Thank you.